Are you drowning in data? Surf the wave of big data with AWS Athena, where queries are quick, smart, and won't break the bank. Discover how. Key challenges in querying a data lake. Data lakes have become integral to organizations dealing with enormous amounts of data. However, they present several challenges like following. 1. Querying large-scale data efficiently. Traditional querying methods struggle with the vast volumes of data spread across numerous storage locations, whereas they support one source at a time. Cost management. Dedicated infrastructures for data querying are costly, especially with variable workloads. We always have to maintain infrastructure to support peak loads or a query which takes higher computing. Ease of use. Teams proficient in SQL may find it difficult to adapt to new query languages or custom APIs. Integration and compatibility. The variety of analytics and data management tools in use can lead to compatibility issues. Handling diverse data formats. Multiple data formats mean additional processing is often required to standardize data before querying. Decoupling computing and storage. Traditional data warehouses that scale compute and storage together can lead to inefficiencies and high costs. Security and compliance. Ensuring the security of data and compliance with regulations is a significant concern during data querying and analysis. Let's explore Athena. What is Amazon Athena? Amazon Athena is an interactive query service that makes it easy to analyze data in Amazon S3 using standard SQL. Key features. Serverless. No server management or setup is required. SQL based. Users can run queries using standard SQL, which is familiar to most data analysts and developers. Athena is particularly useful for quick ad hoc querying in data lakes, where it can access data directly from S3 buckets in variety of formats such as JSON, CSV, Parquet, and any other formats. How Athena addresses these data lake challenges? AWS Athena emerges as a serverless solution addressing these challenges effectively. We'll go one by one. Efficient large-scale data querying. Athena allows fast SQL queries directly against data stored in S3 without complex ETL processes. Cost effective. With no infrastructure to manage, costs are based on the volume of data scanned by each query, not on the provisioned capacity or the server time. So you pay only for the queries you run, saving costs significantly. Ease of use with SQL. Athena uses standard SQL, reducing the learning curve and enabling immediate data analysis. Seamless integration. Athena is compatible with variety of AWS sources, particularly with AWS Glue for data cataloging. Direct querying across formats. Athena queries multiple data formats directly, eliminating the need for data transformation for analysis. Independent scaling of compute and storage. By decoupling compute and storage, Athena offers flexibility and improved resource utilization. Robust security and compliance. Integrating with AWS IAM, Athena ensures secure access to datasets and supports encryption, addressing compliance requirements. Let's see Athena in use with live demonstration. I'm going to demonstrate how to query a dataset that is stored in AWS S3 bucket using Amazon Athena. Okay, I'm in AWS Management Console. I have recently accessed Athena, so you can see that Athena from recently visited, or otherwise you can search for Athena service. Go to Athena service and you see on the left side we have a data source, AWS data catalog, database and table. If we want to query dataset, first we need to create table for the dataset. Let's go to S3 bucket. I have a bucket created which has two folders, one folder Athena and another folder loan borrowers. Athena folder is created if I want to store Athena query results into a bucket location, so this is where I'm going to store. And loan borrowers, this is where I'm going to keep my source data. So you can see that I have two data sets. The first, I'm going to upload the first data set right now. Okay, I'm uploading it. It will take a few seconds. Okay, upload is successful, it's completed. You will see the data set here. Okay, so now let's go back to Athena query editor. Okay, so now I need to create a table for the data set. So there are a couple of ways to do it. One, you can create the table manually, or you can use the AWS Glue crawler. Creating manually is a very laborious process. So the preferred approach is that using AWS Glue crawler. Let's open it from here. Okay, I'm going to name it as borrowers. Is there already glue table created? No, not created. If it is created, yes, you will say yes, and then you select what is the table that is created. As we haven't created the table, no, it is not created. Because we haven't created, it is asking the data source. So when we select the data source, it will go through the data source and try to create the table out of this source. Okay, so here we need to give the S3 path. I'm selecting loan borrowers. This is the folder where we have the data set. Okay, I chose that. It's good. Crawl all subfolders. If I'm going to place it in the future, add an S3 data source. Okay, we added the S3 data source. Next. Okay, so I need to give IAM role to this crawler. I'm going to use AWS Glue service role default, and if you click next. So which database you want to create this table? I have one database created, it's called Loan Management System, LMS. I'm selecting that. You can add a prefix if you want this prefix to be part of your table name, or otherwise you can leave it blank. And you have a crawler scheduler, that is, I'm going to leave it as on demand. Click next. Okay, so now create crawler. Okay, crawler successfully created. Okay, now I need to run the crawler. Okay, crawler is running. It will take a few seconds up to a minute time. If you want, you can access the CloudWatch logs and everything from here, how the crawler is running. If there are any errors or warnings, you can get them in the CloudWatch. Okay, the crawler run is completed successfully. Now let's check if the table is created for this by this crawler. Okay, you can click on the table, refresh. Okay, so you see there is a table created, loan borrowers. Okay, you see the schema, the entire schema is created. It scrolled through the file and created schema based on the first row of the CSV file. It is also assigned the data types for all the columns. So now we can query the data set from Athena. Let's refresh this. Okay, you see the loan borrowers, preview table. It's running. Okay, you see the data. Because I set the limit to 10, you are seeing 10 rows. Okay. Now you can write whatever the queries that you want, and then you can get the result. So, okay, for example, if you want to just limit it to 5 and say that, and then you run it, you will get it 5. Okay. Let's go back to the schema. Here there is some scenarios you may not get the data type correct, but if you want, you can come here, you can edit the data type. Right now, let's see. Okay, original loan term. It is taken as a double, but it should be integer. Okay, let's edit the schema. Where is the original loan term? Okay, you can see that what I'm saying. If you go to query editor, original. Okay, loan term. This is the number of months this loan term is for. So it's a 360 months. Basically, it's a 30 years. So the number of months is an integer. It is not a double. You can come here and we can edit, change it from double to int. You can save it. So when you save it now, so it will create a new version for the schema. Okay. So now you go back, refresh. Run again. Okay, you see that the float has gone. So now you see the integer number here. Okay. So see how easy it is to get the table created through crawler, and you can query the data set from Athena. Okay. Now let's use okay, that's one data set. So what happens if you want to add more data, how easy it is to add additional data and query the additional data. Okay, let's go to S3 bucket, and we already have another data source we have. Okay, let's upload this data set. Okay, before upload, let's go back to the query editor. Okay, I'm going to look for various sequence equal to. Let's see if this data is there or not. Okay, there is no record with the sequence number 200,000. Okay, so now let's upload this file, second data set. Okay, it's been uploaded successfully. Now let's go to Athena and then try run again. There you go. You just uploaded there, you got the data here. So that's how easy it is to use Athena and how flexible for us to query large data sets using Athena.
Limitations. AWS Athena is a powerful tool for querying data stored in Amazon S3 using SQL, but like any technology, it has its limitations. Understanding these limitations can help you decide if Athena is the right tool for your needs. Here are some of the key limitations of AWS Athena. Performance variability. Athena's performance can vary significantly based on data's format and how it is organized. While formats like Paraquet and ORC improve performance due to their columnar storage capabilities, querying large volumes of poorly optimized or non-columnar data like CSV or JSON might result in slower performance. Second, limited data manipulation capabilities. Athena is primarily a query service that does not offer the same data manipulation capabilities as traditional databases. You have a limited insert, update, or delete capability with Athena. For example, you can update or delete rows only in Apache Iceberg tables. Any data modifications must be performed on the underlying data in S3. No built-in materialized views. Unlike traditional SQL databases, Athena does not support materialized views, which can improve performance for frequently executed queries. So here, users must manage their own summary tables or aggregated datasets in S3. Stored procedures. Stored procedures are not supported. You have to rely on other services like AWS Glue and Lambda functions, etc. Data freshness. Since Athena directly queries data in S3, there is a
delay between when data is updated in S3 and when it becomes available for query in Athena. This can be a limitation for real-time data querying needs. SQL function limitations. Athena SQL function library is not extensive as those found in more mature SQL databases. While it covers most common functions, it may lack support for more specialized advanced operations. Despite these limitations, AWS Athena is highly effective for certain use cases, particularly for ad hoc analysis and querying large data lakes where data is not frequently updated. It's best used as a part of a broader AWS data analytics architecture, complementing other services like Amazon Redshift for more intensive data warehousing needs. I hope this video is helpful to you. Have questions or want to see more about specific feature? Please drop a comment below. I would love to hear your thoughts and suggestions for future videos. This is Sagar signing off. Keep transforming and stay data savvy.